Good morning, students. So this is Gnana Saravanan sir. I'm very happy to meet you all once again in this platform. So hope you're doing well and staying safe. So I'm handling you the subject called as Electronic Circuit 1 Lab Component. So even today we have an interesting title or an interesting experiment to deal with. So today's experiment number is experiment number 10 as per our syllabus. It's performance analysis of power supply. So as per the syllabus, it is experiment number 10. As per our sequence, it is experiment number 8. So we have skipped two experiments that is based on field effect transistors. So we are seeing about by BJTs and then coming to power supply. Then we'll go back to FET and MOSFET, right? So that's the sequence. Just aim to have a continuity, right? So what is power supply? So what you see here are two kinds of power supply. So one is a regulated power supply. So this is used even in our lab, right? And the other one is you use it every day. So it's a cell phone charger. So whatever it is, right? So power supply is the basic building block of any equipments. Either it could be a commercial equipments or a domestic experiment. I mean, equipment, right? So the today's experiment we are going to see what will be there. What is the circuit of a power supply, basic power supply, and how to do it, and how what are all the things inside, right? Hope you are interested. Right, let's move further. So the agenda of today's experiment is to design a full wave rectifier, right? And then in that we have only two targets to measure the ripples. Ripples are the AC component that is present in the DC output. Means the output that comes out of the rectifier is a pulsating DC. So it has DC component as well as AC component. So what's the amplitude of AC component is what we are going to measure it. And the second one is even if you vary the load, the output should not vary. So that's what we'll call it as regulation, voltage regulation. So we'll check how far this circuit has a regulated output. So that's the two agendas, right? So the equipment components required are given here. So the major component that we require is a transformer. So I've given the rating of the requirement is 9 volt. In our lab, we have 6 volt step down power supply. I mean, the step down transformer, 9 volt and even 12 volt. Whatever it is, it can be of any one of these three things. No, not necessarily in that you need a 9 volt step down transformer, right? You need a center tap transformer. That's the only requirement, right? So we need transformer one number step down, and diode IN4007 two numbers because it's a full wave rectifier. In case of bridge, we need 4 numbers. Then we need an integrated IC, integrated chip, that is IC. So that is the regulator IC 7805. So it can be even 7812. So if we need the output voltage to be 5 volt, then we need 7805. If we need 12 volt, then it is 78112. It's like that, right? Then we need a load resistance 1 kilo ohms. We even need a DRB, decade resistance box, to vary the load resistance and see the voltage regulation. So other than that, we need a multimeter, especially digital type. That will be convenient. Even analog is okay, not necessarily need to be digital. It can be analog, but we are going to use a digital one. Other than this, you have a breadboard, wires, CRO, probes, as usual, right? So moving on to the circuit diagram. So what you see here is the circuit diagram. So this is the transformer. It's a center tap transformer. So 909. So 9 volt, 0 volt, 9 volt, or it can be even 12012 or 606, whatever. So then on the signal lines, you connect to diodes in this fashion. So here is the output. So the DC, pulsating DC will come here. So here is where we are going to see without employing this capacitor and regulated, we are going to see what is the ripple content. Then employing capacitor and the voltage regulator, will be seeing it, what is the output voltage. So here we'll have a load resistance, either 1K, and also we'll have a DRB to vary the resistance and to see how the voltage is getting regulated. So that's the setup arrangement. So that's the circuit diagram, right? Procedure. So the procedure is simple. So connections are given as per the circuit diagram. So this is common for all the experiment. So for this experiment, you'll turn on the transformer and we will measure the output. What's the output, AC output of the transformer? We say 9 or 12 or 6 volts. What's it actually going to be? I said that if it is 9 volt, it will not be exactly 9 volt. It will be around 10 or 12 or 15. So that even if the input falls below 230 and goes to 120, you still get 9 volt. So அந்த மாதிரி தான் டிசைன் பண்ணிருப்பாங்க. அதுக்காக தான் even if it is 9 volt, you get around 12 or 15 volt. If it is 12 volt, you get around to 18 or 20 volt. right? So that even if the input falls down, the output is ensured. So that's the reason. So then we will measure the ripple content of the output after rectifier, without inserting the capacitor filter. Then inserting the capacitor filter and the regulator IC, we'll see what's the output voltage with the regulation. So that's the agenda. We'll tabulate the reading and we'll find out whether what we get practically coincides or falls in the range of the theoretical value. So this is the tabulation. There are two tabulations. So one is, see, the output voltage at the transformer and the overall output voltage after rectification, right? The ripple content practical and theoretical value, and the overall output with the regulator. So that's tabulation and one. And second tabulation speaks about the voltage regulation. You see, the value of the load resistance will be changed step by step, and will note down the output voltage with regulation. Output voltage, most possibly, it will not change. It should not change. If it changes, then the regulation is improper, right? So that's all on the theory side. So now we need to go and check whether things work as we spoke on. Are you ready? Let's go. Go and check how it works. So here is the setup. So as usual, we have function term in CRO. Then we have a multimeter. And then we have a transformer. Then we have the connections as per the circuit diagram. So this is a decayed resistance box. You see here you can vary the values. So let's go on measuring the readings. So this is the actual output at the capacitor. So you have almost a straight line, but there is a small variation. So that small increase and decrease is what you call it as the AC component. So which we call it as the ripples, which we are going to find it out, right? So going on to the circuit. So let me put this in AC voltage. So we need to measure the output voltage at the transformer. Just hold on. So it is around 17.12. Let me check. So 17.12. So transformer output. So it's a 12 volt transformer. So you get around 17.12, right? So that is the output transformer output 70.12. So we have noted it down. Then we need to measure. So here is the rectifier circuit. Now comes, this is the capacitor filter. So at the filter, when you want to measure, you may need to put it in the AC voltage. Especially the AC component will be of low amplitude. So across, hold up. Yeah, across the capacitor, we tend to measure. So it gives a value around 2 millivolt, 1.8 millivolt. So 1.8 millivolt. So 1.8 is nothing but it is 0.01 millivolt, 0.01 volt or 0.15 or 15 millivolt. So we have measured. So then we need to measure what is the output voltage without regulator.
So output voltage. So this is regulator's input. This is ground. This is output. Regulator's input voltage. So here, when you keep it, the output voltage, yeah, it comes around. So the output voltage without regulator comes around 17 volt. So almost it comes nearer to this. So it comes around the output voltage without regulator. In our case, this time it is not 20, it is 17 volt. Now output voltage with regulator. Let me show. So output with regulators is a third pin. Sorry, plus should be here. Minus should be here. Then we need to keep it in DC voltage. Now let me check. You see, it comes around. Just hold on. 5.08. Now I need to. So here it is 5.08 voltage. So this output voltage with regulation, with load changes, is it going to be constant is what we are going to change. So we are going to change the value of this resistance in decade resistance box. So I'll try to keep it in 2 kilo ohms and I'll try to check. So it is 5.04, not much variations, right? So for all the values, it is around 5.04 or 3 or something like that. Not much variation. So we tend to vary the value of this load resistance and still the output is regulator or constant. So that is what voltage regulation means. Now going to the ripple factor, the theoretical ripple factor is calculated using this formula. Say it is 1 by 4 root 3. Frequency, this is F, 50 hertz. F, RL is 1 kilo ohms for our first case. Then capacitor value is 1000 microfarad. When you put that, it is around 0.002. So that's what theoretical value is, 0.002. So in our case, so for measuring the practical ripple factor value, so VAC divided by VDC. So VDC output voltage after the rectifier is 20 volt. It's 20 volt, and VAC, that is the AC component present in the DC. We measured using first reading, right? So it is 0.015. When you put that, the ripple factor comes around 0.002. So the practical ripple factor is also 0.002. So it comes almost the same. So that is as far as today. So that's how on the parts of hope you got an idea, right? So meet you all.